Introduction to Geometry, Level 1. Geometry is extremely useful for engineers, architects, painters, carpenters, teachers, electricians, machinists, home builders, and many more. Geometric principles are important in the construction of buildings and roads, the design and use of machinery, the creation of three-dimensional visuals and effects, and to better understand and unlock the secrets of the universe itself. Like any language and mathematics course, the important ideas in geometry must be developed gradually, with understanding, practice, and effort. Alright, let's get started with the basics. The simplest figure studied in geometry is called a point. Although a point doesn't have any size, it is often represented by a dot, which does have some size. But keep in mind that for the most part, they do not have a size. We use a dot to visually represent a figure that lacks size. We usually name points by using capital letters. For example, the following 5 points are called point A, point B, point C, point D, and point E. All geometric figures consist of points. Another familiar geometric figure is called a line. Lines are made up of points and are straight. The arrows on the end of the figures show that the line extends infinitely far in both directions. They extend forever and ever. Although a picture of a line has some thickness, the line itself has no measurable thickness, so keep that in mind. Unless it is explicitly stated, lines have no thickness. The following figures are examples of lines. There are 2 different ways we can name lines. The first way is by using a single lowercase letter, such as line M. The alternative way to name lines is by using their points. For example, the line on the right contains the points A and B, so we can call the line AB. Using symbols, we can denote it like this: AB with a line on top, or as follows, line BA. Both ways are acceptable, but for the most part, we denote the letters in alphabetical order, so AB will be the typical way to denote this line. To talk about the next geometric figure, we need to remember a concept learned in Algebra 1. In algebra, you learn that a number line is formed when a numerical value is assigned to each point on a line. For example, the following line represents a number line, and point A is located at -1. Likewise, point B is located at 1.5, or written another way as 1.5. We need to understand number lines in order to understand line segments, or simply segments. Like lines, segments are made up of points and are straight. What distinguishes them from lines is the fact that line segments have a definite beginning and end. In other words, they are measurable. They do not extend forever and ever in both directions like lines do. The following are examples of line segments. The line segment on the left can be denoted as AB or segment BA. Notice that we add a segment on top of the letters in order to distinguish it from that of a line, which contains arrows in both ends. Also notice that a segment is named in terms of its 2 endpoints, because a segment has a definite beginning and end. The figure in the middle contains 2 line segments. The vertical, up and down segment can be called RS or segment SR. Once again, we usually denote them in alphabetical order. The horizontal, crosswise, or from left to right, can be named as segment ST or segment TS. In the following number line, the segment whose endpoint is located at the coordinate of -1 and 1 is denoted as line segment BD or segment DB. Likewise, a segment that has a coordinate at -2 and 2 is denoted as segment AE or segment EA. So we learn about lines which extend forever and ever in both directions, and we learn about segments which have a definite length and do not go on forever and ever. Is it possible to create a figure that contains both of these characteristics? The answer is yes. These hybrids are called rays. Rays, like lines and segments, are made up of points and are straight. A ray differs from a line or segment in that it begins at an endpoint and then extends infinitely far in one direction only. Lines extend in 2 directions. Rays extend in 1 direction only, so make sure you keep that in mind. The following are examples of rays. Now when it comes to denoting them, we actually need to be careful and make sure we start denoting a ray by naming its endpoint first. This way it becomes clear where the ray begins. So the ray in the left is denoted as ray AB. Notice that we add a ray on top going from left to right. This is the appropriate way to denote rays. It would be completely wrong to denote the ray as ray BA. Remember, we want to start with the endpoint first. The ray on the right can be called ray RS or ray RT. As long as the endpoint is given first, any other point on the ray can be used to denote the ray. Now that we know about points, lines, segments, and rays, we can now talk about angles. In essence, an angle is made up of two rays with a common endpoint. This point is called the vertex of the angle. The rays are called sides of the angle. There are various ways that angles can be described and denoted. For example, if we place the number 1 inside the angle near the vertex, like this, we would denote this angle as angle 1. The symbol that we use to denote angles is drawn as follows. It's essentially a picture of an angle. If the angle only contains one letter in the vertex, then you denote it as angle A. When you denote the angle using one letter, make sure you name the point on the vertex. An alternative way is needed if the angle is described in terms of 3 points. For example, if this angle has a vertex labeled as A, and the other points are B and C respectively, then we need to denote the angle as follows. Angle BAC, or angle CAB. Notice that when we use 3 letters, the vertex, in this case A, must be named in the middle. Make sure you always do this. If we take the same angle and draw another ray from point A to point D, we would end up with 3 new angles. Make sure you can see them. The first angle is formed by points BAD and is denoted as angle BAD or angle DAB. The second angle is denoted as angle DAC or angle CAD. And the third angle is denoted as angle BAC or angle CAB. Notice that if we try to denote any of the angles by using only one letter, such as angle A, we will be totally confused what angle we are referring to, because all the angles share the same vertex. So in this case, it is really convenient to use 3 letters to name the angles. Alright, the final figure we will talk about is formed by using 3 segments and combining them in the following way. The figure that we just created is called a triangle, and we denote it as follows. Triangle ABC or triangle ACB or triangle CBA or triangle CAB or triangle BAC or triangle BCA. Notice that the letters need to start at one point and move either clockwise or counterclockwise when denoting them. The convenient way is once again by using letters that are in alphabetical order whenever possible. So triangle ABC will be the best way to describe this triangle. Notice that a triangle has 3 segments as its sides. Notice that there seems to be 3 angles, but they contain no rays. Nevertheless, this figure contains 3 angles. They are angle A, angle B, and angle C. If you recall from your algebra class, we often talked about sets. Well, it turns out we can think of a triangle as being a union of 3 segments, and can be denoted using set notation as follows. Triangle ABC is equal to segment AB union with segment BC union with segment AC. Likewise, the intersection of any 2 segments or sides forms the vertex of a triangle and can be denoted using set notation as follows. Vertex A is equal to segment BA intersected with segment AC. Vertex B is equal to segment AB intersected with segment BC. And vertex C is equal to segment AC intersected with segment CB. Alright, and there you have it. These are the basic building blocks of geometry, and this is only the beginning. To recap, we learned about points, which have no sides, but we draw a point to visually represent one. We also learned about lines, which contain points and extend infinitely in both directions. This is represented by the arrows that point in both directions. We also learned about segments, which have a definite length. In other words, they are measurable. As a consequence, they have a beginning and an end, which are called the endpoints of the segment. We also learned about rays, which share the characteristics of a line and a segment. It contains an endpoint in one side and contains an arrow in the other side, which extends infinitely in a direction it is facing. When we have 2 or more rays that share a common point called a vertex, we form angles. And finally, when we connect 3 line segments together, forming 3 distinct vertices, we create a triangle. Okay, Make sure you are familiar with all these figures, an appropriate way to denote and name them. In our next video, we will practice denoting and naming figures with various examples.
Introduction to Geometry, Level 2. Alright, in this video, we are going to practice drawing, denoting, and naming figures with a couple of examples. To be successful in geometry, you need to be able to read and describe the basic building blocks of geometry, both pictorially and symbolically. Let's go over the first example. Draw a figure that represents the following symbols: line segment PQ, line PQ, ray PQ, angle PQR, and triangle PQR. Alright, the first symbol represents a line segment, since there is a line segment drawn directly above the letters. We can draw this segment by drawing 2 points, P and Q, and connecting them with a straight line, as follows. Remember, line segments have a definite length. They have a beginning and an end. They do not extend forever and ever, in either direction. The next symbol represents a line, since there is a line with arrows pointing in opposite directions drawn directly above the letters. This is similar to a line segment. The only difference is that this line extends infinitely in both directions. We show this by drawing arrows on both ends. So we first draw points P and Q, and then we connect them, making sure we draw arrows on both ends, as follows. The next symbol represents a ray, since we have a line that extends in one direction, drawn directly above the letters. The first letter in the symbol always represents the end point of the ray. Keep this little detail in mind. So we first draw points P and Q, and then draw an arrow that extends from point P towards point Q, as follows. It would be incorrect to draw this ray the other way around, since the symbol is stating that the endpoint starts at P, not point Q. The next symbol represents an angle. For the most part, we denote angles using 3 points. The middle letter always represents the vertex. So we go ahead and draw point P, Q, and R. Then we draw 2 rays, both emanating from the vertex Q, as follows. You need to make sure that the vertex is being represented by the middle letter, in this case, point Q. It is very important to pay attention to these little details. The final symbol represents a triangle, and like an angle, it also requires 3 points. In this case, each of the points will be connected by a line segment. So we first draw points P, Q, and R. Then we go ahead and connect them in the order represented by the symbol. So P connects with Q, and Q connects with R. And lastly, you form the triangle by connecting point R and P. Make sure you're comfortable reading and drawing the various types of lines, rays, angles, and triangles, since you will be reading and drawing them extensively in your geometry class. It is important that you master this skill before we tackle more challenging problems in geometry. Alright, now let's practice denoting and naming geometric figures. Let's move along to the next example. What are the 3 possible names for the lines shown? Recall that lines contain arrows pointing in opposite directions and can be denoted by using 2 points. In this example, the line shown can be denoted by using point C and point D. So we can name the line as line CD or line DC, making sure we draw a line directly above the letters. Alternatively, we can also name this line as line L, since this line is also labeled with a lowercase letter. Keep in mind, when we use 2 points to denote a line, we usually want to express the points in alphabetical order. Nevertheless, both expressions are acceptable ways to name the line. Alright, let's try the next example. What are the 4 possible names for the angle shown? The following angle can be named in various ways. Since this diagram only contains a single angle with point E as its vertex, we can use the vertex to name the angle, in this case, point E. So we can name this angle as angle E, making sure we draw the picture of an angle followed by the letter of the point that represents the vertex. Alternatively, the angle is also labeled with the number 5. so we can also name this angle as angle 5. We can also name angles by using 3 points. In this case, we can use point C, E, and D to name the angle. So we can name this angle as angle CED or angle DEC, making sure we write the point that represents the vertex in the middle. Just like lines, we usually want to denote the points of an angle in alphabetical order, whenever possible. Nevertheless, both forms are acceptable ways to name this angle. Alright, let's try the next example. Name the sides of triangle RST. Here we have a triangle. Recall that triangles contain 3 angles, hence the name triangle. This also means that triangles are formed by 3 sides. We can name the sides the same way we name line segments, by using 2 points. In a triangle, the points we will use are the ones located on each vertex of the triangle. These vertices are essentially the endpoints of a line segment. The first side contains points R and S and can be named as line segment RS or line segment SR. The second side contains points S and T and can be named as line segment ST or line segment TS. And a third side contains points R and T and can be named as line segment RT or line segment TR. Making sure we draw a line segment to symbolically show that we are referring to a line segment, not to be confused with rays or lines. Once again, it is very important that you master the skill of drawing, denoting, and naming figures. In our next video, we will practice how to name and denote angles. Introduction to Geometry, Level 3. In this video, we're going to practice denoting and naming angles by using various points located on a geometric figure. Let's go ahead and jump straight into the first example. Using the following figure, find the following. Name angle OPR in all other possible ways. The following figure is a type of quadrilateral, since it is formed by 4 sides, as opposed to a triangle, which is formed by 3 sides. We will study quadrilaterals in a much later video. For now, the problem is asking us to name angle OPR in all other possible ways. Let's first figure out where angle OPR is located on the figure. So we first locate point O and move towards point P, and then we move towards point R. From the way the angle is denoted, we know that the vertex of that angle is located at point P and is formed by rays PO and PR. The angle in question will be the following highlighted angle. Now, you might be tempted to use vertex P and name this angle as angle P. Unfortunately, this would be incorrect, since point P is also the vertex of another angle, specifically this one. So we can't name angle OPR as angle P, since this point is also the vertex of another angle. This would be confusing to someone who is trying to locate angle OPR. In an effort to avoid any confusion, we need to name this angle in other ways. One alternative way we can name this angle is by reversing the order of the points and name it as angle RPO, making sure we denote the vertex P in the middle. Yet another way to name this angle is by using point S, since it is located in the same line containing points P and O. So we can name this angle as angle SPR or angle RPS, making sure we denote the vertex P in the middle. Notice that the figure does not use numbers to label the angles. As a result, we are essentially done covering all the possible ways to name this particular angle. Alright, let's try the next example. What is the vertex of angle TOS? Remember, the vertex of an angle, when denoted in this particular way, is represented by the middle letter. In this case, the vertex of this angle is point O. In the figure to the left, this is the location where rays OT and OS intersect. You can also think about a vertex as the intersection of these 2 rays. Using set notation, we can denote them as ray OT intersected with ray OS. We will cover problems involving set notation in a later video. Now let's move along to the next example. How many angles have as its vertex point R? First, let's locate point R. Point R is located on the bottom right corner of the figure. Notice that this point is the vertex of three distinct angles. The first angle can be named as angle PRO, or angle ORP, or angle PRT, or angle TRP. The second angle can be named as angle ORS, or angle SRO, or angle SRT, or angle TRS. The third and final angle can be named as angle PRS, or angle SRP. So in total, there are three angles that have point R as its vertex. Alright, let's try the next example. Name angle TSP in all other possible ways. Okay, let's first identify what angle the problem is referring to. So let's start at point T and move towards point S, and then move towards point P. So this is the angle referenced by the problem. One way we can name this angle is by switching the direction of the points and name it as angle PST. In addition, we can also use point O to name this angle, since it's located on the same line that contains point P and S. Using this point, we name this angle as angle OST, or angle TSO. Once again, since this figure does not use numbers to label its angles, these are essentially all the possible ways to name angle TSP. Alright, let's try the final example. How many triangles are there in the figure? At first glance, it seems that there are 4 triangles in the figure. They include the triangle on the left, which can be named as triangle TOP, the triangle on the right, which can be named as triangle SOR, the triangle on the top, which can be named as triangle TOS, and the triangle on the bottom, which can be named as triangle POR. It turns out that there are actually other triangles that are formed by these 4 smaller triangles. The first one can be named as triangle PTS. The next one can be named as triangle TRS. Another one can be named as triangle SRP. And the last one can be named as triangle RPT. So there are a total of 8 triangles in this figure. Alright, in our next video, we will continue denoting and naming more challenging angles by using the points located on a geometric figure. Introduction to Geometry, Level 4. In this video, we're going to continue denoting and naming slightly more challenging angles by using the points located on a geometric figure. Let's go ahead and start with the first example. Using the following figure, find the following. Name the vertex and the sides of the following angles: angle 4, angle 1, and angle 6. Alright, we are asked to identify the vertex and the sides of the given angles. Let's start with the first angle. Angle 4 is located here, and its vertex is represented by point C. Now, the sides of the angle are formed by rays CD and CB. Notice that ray CB can also be named as ray CA, since both points B and A are located on the same line segment. So this ray can be named in both ways, as long as you denote the vertex C first, followed by point B or A. Also notice that the arrows on each ray are not drawn in the figure. Recall that the sides of an angle are technically formed by rays. When you name the sides of angles, we usually name them as if they were rays. Even though the ray is not explicitly drawn in the picture, we still denote them as if they were rays. In the same manner, let's locate angle 1. Angle 1 is located here, and its vertex is represented by point A. The sides of angle 1 are formed by ray AD, which can also be denoted as ray AE. The second side of the angle is formed by ray AB, which can also be denoted as ray AC. Lastly, let's locate angle 6. Angle 6 is located here, and its vertex is represented by point D. The sides of angle 6 are formed by ray DC and ray DB. Notice that the angles of this geometric figure are labeled with numbers, which makes it slightly easier to reference a particular angle. Alright, let's move along to the next example. Name 3 angles that have B as the vertex. Let's first locate point B. Point B is located right here. At first glance, it seems that there are 2 distinct angles that have point B as the vertex. The first of these angles is angle 3. Notice that we can also name this angle as angle DBC or angle CBD. Another angle that contains point B as the vertex is angle 2. We can also name this angle as angle DBA or angle ABD. It seems that these are all the angles, but the problem is asking us to name 3 angles. We already found 2 angles. Now it's just a matter of finding one more angle that has B as the vertex. At first, it might be hard to see, but the third angle is formed by point C, point B, and point A. This angle is usually referred to as a straight angle. You can think of this angle as a sum of angle 3 and angle 2. Straight angles will be discussed in more depth in a later video. For now, keep in mind that these types of angles exist. With that said, we can name this angle as angle CBA or angle ABC. Alright, let's try the final example. Name all the angles that have D as the vertex. Alright, let's take a look at point D. Right off the bat, it seems that there are 3 angles that contain point D as the vertex. They include angle 7, which can be named as angle EDC or angle CDE. Angle 6, which can be named as angle CDB or angle BDC. And angle 5, which can be named as angle BDA or angle ADB. These 3 angles are the obvious angles that have D as the vertex. But it turns out that there are 3 additional angles that contain point D as the vertex. The next angle is formed by the sum of angle 7 and 6, and can be named as angle EDB or angle BDE. Another angle is formed by the sum of angle 6 and 5, and can be named as angle CDA or angle ADC. The final angle is formed by the sum of angle 7, 6, and 5, and can be named as angle EDA or angle ADE. This is another example of a straight angle. Going over these examples, I want to point out the importance of developing your ability to see and identify the various angles that exist within a geometric figure. It is going to be vital as we tackle on more challenging problems in geometry. Alright, in our next video, we will start going over examples that requires us to use concepts associated with sets, such as unions and intersections of geometric figures. Introduction to Geometry, Level 5. In this video, we're going to go over basic examples that ask us to find the intersection and union of various geometric figures. Before we jump into some examples, let's refresh our memory and talk about sets. Say I have 2 distinct sets. Let's call them set A and set B. Recall that a set is a collection of objects. These objects are referred to as the elements of the set. In this example, the numbers 1, 2, 3, 4, 5, and 6 are the elements of set A. Likewise, the numbers 2, 4, 6, 8, 10, and 12 are the elements of set B. When dealing with sets, we are often asked to find the union or intersection between 2 or more sets. If we are asked to find the union between set A and B, we would denote it as follows: A union B. This symbol is pretty easy to remember, since it resembles the letter U for union. In essence, the union between 2 sets consists of all the elements in A or in B or in both. You can think of a union as the process of merging the elements of both sets together. In this example, A union B will be equal to a new set that contains every element that is in either set A or set B, including those elements that are common to both set A and B. In contrast, if we are asked to find the intersection between set A and B, we would denote it as follows. A intersection B. This symbol looks like an upside down U, and it sort of looks like the capital letter A if you use your imagination. Imagining the capital letter A will remind you of the word AND, since the intersection of two sets creates a new set containing the elements in both A and B. In this example, A intersected B would equal to the set containing the elements 2, 4, and 6, since these elements are in both A and B. Graphically, you can see the reason why this is called the intersection between two sets. It's literally an intersection or overlapping of common elements. The final concept we need to be familiar with is the idea of an empty set. Let's take set A and set B and remove the elements common to both sets. Now, if we were asked to find A intersection B, we would see that there are no common elements between set A and B. In this case, we would obtain what is referred to as an empty set, and we use this symbol to denote the empty set. An empty set is special in the sense that it contains no elements. Alright, now that we are refreshed and familiar with the concepts associated with sets, let's go ahead and try the first example. Use the following figure to answer the following questions. How many lines are shown? Name these lines. By looking at the figure, we can see that there are two distinct lines, so the answer to the first question is 2. Now, the second question is asking us to name them. Let's focus on the line that contains points D, B, and E. This line can be named by using 2 points, so we can name this line as line DE, or line DB, or line BD, or line BE, or line EB, or line ED. Notice that this line is labeled with the lowercase letter m, so we can also name this line as line M. In the same manner, the line that contains points A, B, and C can be named as line AB, or line AC, or line BA, or line BC, or line CB, or line CA. Remember, lines can be named by denoting 2 points located on the line, or by using a lowercase letter whenever possible. Alright, let's try the second example. Where do line AC and line DE intersect? Using set notation, this problem translates to the following expression. Line AC intersection line DE. Looking at the lines, we see that they intersect at a common point, in this case, point B. So line AC intersection line DE is equal to point B. Let's try the next example. Where does ray AC intersect line BC? Using set notation, this problem translates to the following expression. Recall that you can think of a ray as being the set of all points that starts at one endpoint, in this case point A, and goes in the direction of another point, in this case point C. In the same manner, a line is a set of all points that extends infinitely in both directions. So the following points are located on line BC. For this problem, we are looking for the points that both ray AC and line BC have in common, hence the intersection. In this case, the common points start intersecting at point A and extend infinitely in the direction of point C. Therefore, the intersection of ray AC and line BC is equal to ray AC. Alright, let's try the next example. What is the union of ray BA and ray BD? Using set notation, this problem translates to the following expression. First, let's locate each of the rays. Ray BA is located here, and ray BD is located here. You can think of the union as a merger between these two rays. We want to include all the points on ray BA or BD, or in both. Recall that an angle is formed when two rays have a common point of intersection, called the vertex. This is essentially what happens when we form the union of these two rays. Therefore, the union of ray BA and ray BD is equal to angle ABD or angle DBA. Alright, let's move along to the next example. Find the intersection of ray AB with ray CA. Using set notation, this problem translates to the following expression. Once again, let's identify the set of all points located on ray AB. Then we need to identify the set of all points on ray CA. Now it's just a matter of finding where the set of points of these two rays intersect. We see that the set of points on both rays start intersecting at point A and end at point C. In essence, the set of points intersect along a common line segment, in this case, line segment AC. So the intersection of these two rays is equal to line segment AC. Alright, let's end the video with the final example. Find the intersection of triangle ABC and ray DE. Using set notation, this problem translates to the following expression. The set of all points located on triangle ABC are represented as follows. And the set of all points located on ray DE are represented as follows. For this problem, we're looking for the intersection of these two set of points. Notice that both sets intersect at a common point. In this case, they intersect at point F. So the intersection of triangle ABC and ray DE is a set containing point F. Alright, in our next video, we will continue covering slightly more challenging examples involving the union and intersection of geometric figures. Introduction to Geometry, Level 6. In this video, we're going to use the following figure to find the union and intersection of various lines, line segments, and rays. Recall that the symbol for denoting the union of two sets is this U-shaped symbol. It is essentially a U for union. The symbol for the intersection of two sets is an upside-down U. It is important to understand that when we are dealing with lines, line segments, and rays, a set will consist of all the points that a particular line, line segment, or ray is composed of. For example, you can think of a line as a set of all points that extend infinitely in both directions. A line segment is a set of all points that starts at one point and ends at another point. And a ray is a set of all points that starts at one point and extends infinitely in one direction. With that said, let's go ahead and start with the first example. Use the following figure to find the following unions and intersections. In this first problem, they are asking us to find the intersection of line segment AD and DC. If we think of line segment AD as a set of all points that forms this line, we would obtain the following points. In the same manner, the set of all points that form line segment DC will consist of the following points. Since we're trying to find the intersection of these two set of points, we see that both lines contain one point in common. In this case, point D. So the intersection of line segment AD and DC is a set containing only point D. Now let's try the second example. In this problem, they're asking us to find the union of ray EC and ray EA. Notice that the diagram does not contain any arrows. Nevertheless, we can either imagine or add the arrows in the diagram when needed. For this example, we are referring to ray EC, which is a set of all points located here, even the points that extend infinitely in this direction. In the same manner, the set of all points of ray EA are located here. Again, even the points that extend infinitely in this direction. Since we are asked to find the union of these two set of points, we essentially want to unite or merge all the points from both rays, forming a new set. This new set will form a line which can be denoted as line AC or line CA. We can also argue that the union of these two rays also forms an angle. In this case, we form a straight angle, specifically angle AEC or angle CEA, with the vertex located at point E. Straight angles will be discussed more fully in a later video. For now, either the line or angles are acceptable answers for this problem. Alright, let's go ahead and try the next example. Here we are asked to find the intersection of line AC and line BD. The set of all points forming line AC are represented as follows, and that of line BD are represented as follows. Since we're looking for the intersection of these two lines, we see that they have point E in common. So the intersection of these two lines is a set that contains point E. Alright, let's move along to the next example. Here we need to find the intersection of line segment BC and line segment AD. The set of all points that are associated with line segment BC are represented as follows, and those associated with line segment AD are represented as follows. Notice that none of the points of either line segment BC or line segment AD intersect. This means that there are no points that both line segments have in common. This results in an empty set, which is represented by the following symbol. Okay, let's try the next example. Here we need to find the intersection of ray AC and ray EC. Here we have to be careful, since the way we denote rays is going to be key in this problem. The first letter on a ray represents the endpoint, and the second point is in the direction in which the ray infinitely extends towards. The set of all points of ray AC is represented as follows, and the set of points of ray EC is represented as follows. For this problem, we're looking for the intersection of these two rays. This occurs in the following region. Notice that it forms a ray with endpoint located at point E and extends infinitely towards point C. So the intersection of these two set of points is the set of all points that forms ray EC. Alright, let's proceed to the next example. Here we need to find the union of ray DA and ray DC. The set of all points represented by ray DA consists of the following points, and the set of all points represented by ray DC consists of the following points. Since we're looking for the union of these two rays, we see that we essentially form angle ADC or angle CDA, with vertex located at point D. Remember, when we are asked to find the union of two sets, we want to merge all the elements together. In this case, all the points that are located on ray DA or ray DC or in both. Alright, let's end the video with the final example. Here, we need to find the union of line segment EC, line segment CD, and line segment DE. Notice that we have three distinct sets. The concepts and ideas are the same, regardless of the number of sets. So don't panic if you get a problem that contains multiple sets. Alright, the set of all points represented by line segment EC consists of the following points. The set of all points for line segment CD are represented as follows, and a set of points of line segment DE consists of the following points. Since we're trying to find the union of all these points, we see that by merging all these points together, we create a new set. We create a new set of points that represents a triangle, specifically triangle ECD, or written in other ways as triangle CDE, or triangle DEC, or triangle DCE, or triangle CED, or triangle EDC. As long as you label the points forming the line segments or sides of the triangle clockwise or counterclockwise. Alright, in our next and final video on this section, we're going to go over more challenging problems that ask us to name and find the union and intersection of geometric figures. Introduction to Geometry, Level 7. In this final video, we're going to go over various examples and use all the concepts learned from the previous videos. Let's go ahead and jump straight into the first example. Name in all possible ways the line containing point A, R, and D. Alright, let's first locate points A, R, and D. Notice that these points lie in the same line. Recall that we symbolically denote lines by using the letters of 2 points and drawing a line directly on top of the letters. For this example, the line containing these 3 points can be named as line AR, or line AD, or line RA, or line RD, or line DA, or line DR. A total of 6 distinct ways. For the most part, we usually want to use the expression that is in alphabetical order, whenever possible. Alright, let's try the next example. Name the sides of angle ABC. Let's first identify angle ABC. so we need to locate points A, B, and C. Having found the points, we see that we are dealing with the highlighted angle that contains point B as its vertex. Recall that angles are formed by two rays. For this angle, the two rays are ray BA and ray BC. We need to make sure that we label the vertex first, since this is technically the endpoint of each ray. Keep in mind, when you denote rays, the order of the letters matter. We need to write the endpoint first, followed by a second point. This second point indicates the direction that the ray infinitely extends towards. Alright, let's move along to the third example. Name the horizontal ray with endpoint B. Here they are asking us to identify a horizontal ray that has B as its endpoint. It is very common for students to confuse a line that is horizontal and a line that is vertical. A horizontal line can be thought as a flat or leveled line and extends to the left and to the right. You can think of the floor that you walk on as a horizontal surface. A vertical line can be thought as being upright. It extends down and up. You can think of the walls in a room as vertical surfaces since they are upright relative to the floor. For this problem, we want to identify a horizontal ray. So if we were to use point B as one endpoint, we see that the only horizontal ray that can be formed is ray BC, and this is our answer. Alright, let's move along to the next example. Which angle in the figure is angle B? Alright, we are asked to identify which angle can be named as angle B. Notice that point B is the vertex of three distinct angles, specifically angle 1, angle 3, and angle ABC, also known as angle CBA. Since point B corresponds to the vertex of three distinct angles, none of the angles can be solely called angle B. We will need to be more specific and use either the numbers or points to denote specific angles. Alright, now let's try some union and intersection problems. For these problems, you want to identify the line segment, ray, or angle specified, and determine the intersection or union. Let's first identify ray EC. Recall that we can think of this ray as being formed by a set of points which are represented as follows. In the same manner, ray FA is represented by the following set of points. Since we are looking for the union, we need to locate all the points on ray EC or ray FA or in both. We see that this new set forms line AC or line CA. Alright, let's try the next example. Instead of finding the union, we now want to find the intersection of these two rays. Let's go ahead and show the set of points for each ray once again. Now we want to find the intersection of these two rays. So we're looking for the region where the set of points intersect. This occurs at a line segment. So the intersection of ray EC and ray FA creates a set of points that are located on line segment EF, also known as line segment FE. Alright, let's proceed to the next example. Like always, let's mentally visualize the set of points that form ray BA and a set of points that form ray BE. In this problem, we want to find the union of these two rays. We will create a new set that contains the points of ray BA or ray BE or both. Notice that when we merge these two sets together, we end up forming an angle. Specifically, angle ABE or angle EBA, or more simply as angle 1. Okay, let's go to the next example. Alright, same deal. Let's mentally visualize the set of all points that forms each of the lines. For line AC, the set of points are represented as follows. And for line DR, the set of points are represented as follows. For this example, we want to find the intersection of these two lines. Looking at the set of points from both lines, we see that they have a single point in common, or single point of intersection. In this case, the intersection of line AC and line DR is equal to point A. Alright, let's end the video with the final example. The set of points represented by angle AFD are shown as follows. In the same manner, the set of points represented by line segment CE are shown as follows. we are asked to find the intersection of these two set of points. Observing the points of intersection, we see that they intersect at a given line segment. So the intersection of angle AFD and line segment CE forms the set of points located on line segment EF, or written another way as line segment FE. Alright, with the skill to identify and name the basic elements in geometry, we are ready to move along and dive deeper into the concepts of geometry. In our next series of videos, we will learn how to measure segments and angles, as well as classifying angles by size.